Welcome to Explore Embedded. This is in-depth video on discussing the HD44780 character LCD controller. If you are moving ahead from the basic video, we would go ahead and look at all the internal details of the HD44780, which is used in many of the character graphics LCDs like the JHD162, which is 16x2, or JST161A, and many other LCDs of these types. Now this will be in-depth tutorial. We'll be discussing the entire internal structure, the instruction set, and how to even display custom characters on a character LCD. Now, if you have watched the basic video, if you are curious on many questions as to why particular commands were used, then you should go ahead. If you simply want to use the displays, you're better off with the first video. Alright, then let's go ahead and look at this particular graphics controller. Now, what you could observe here is a character on a graphics LCD. It's matrix of 5 columns and 8 rows. So this is pretty straightforward. So whenever we want to display a particular character and we give ASCII value to the controller, and basically this is all inside LCD display. So the entire stuff is inside the LCD display. Now, so whenever we give ASCII value to the LCD controller, it creates a pattern, or it generates a character, and it displays it in a matrix form on a 5 column and a 8 row matrix. So again, there are two types. So basically the first is the 5x8, and there are even 5x8, and there are even displays with dot matrix of 5x10. So the overall functionality would be exactly the same. We just need to configure the display depending on whether it supports 5x8 matrix or 5x10 matrix. Now, to do that, what a controller or what a graphics controller does is it has 40 segment lines, as you could see here. So these 40 segment lines, and along with the there are 16 common lines, and so this 40 segment lines along with 1 to 8 common lines, they form 8 characters. So you could see a 1, 2, 3, 4, 5, 6, 7 and 8. So these are 8 characters. Now with another 8 common lines, it displays another 8 characters. Now with the basic HD44780, you can display 8 characters on 2 lines. But if you want to say display 16 characters on 2 lines, what you have is extension controller, or it just extends these 8 characters to the next 8, so it becomes 16. Likewise, you can have 4 such extenders, and then both the lines would be extended, right? So the segment lines 1 to 40. So as you could observe here, each character gets 5 of these lines, and there are a total of 40, so that we can display 8 characters on a line. So common 1 to 8, it is used for first 8 on line 1, and common 9 to 16 are used for next 8 characters on line 2. Now let us go ahead and see as to what arrangements are done with respect to the extension controllers. So for a simple 16x1 display, so the common lines 1 to 8, they give us the first 8 characters, and there is no extender required. So the next 9 to 16 characters are displayed with the common 9 to 16 lines. So these are the first 8 and these are the next 8 characters. So these are total 16 characters on one line. So similarly, for a 20x4 display, you have 4 extension controllers, and likewise even the common lines are switched. So so these are 8 plus 8 plus 4. So these are 20 characters and displayed on 4 lines. So these are total 4 lines and these are 20 characters. So all this stuff is done inside the graphics controller, so you need not worry much about it. But what you should be concerned is actually what commands we need to send to this particular graphics controller so that it displays the correct pattern on the LCD display. So this is our graphics controller, and this is the LCD panel with the segment drivers. So depending on the type of LCD you have, the segment drivers might be 1, 2 or 4. So now this is all inside a liquid crystal display. So now what we have as an interface is the data lines DB0 to DB7. So basically there are 8 data lines, and this is power and contrast, and there are 3 control lines. So this is enable, register select, and read write. Let us look a little more into this particular controller. Right, so what we have inside is, I mean, this could be intimidating, but it's again simple. So there are 2 registers. So this is register, this is the instruction register, and this is the data register. Now if the register select line, if it is 0, the instruction register is selected, and if it is 1, the data register is selected. So whatever data that we send on the data lines 0 to 7, that goes to either the instruction register or the data register depending on the RS line. So if it is 0, it goes to the instruction register. If it is 1, it goes to data register. It is sometimes called as the command register. Now we'll discuss the status register and the busy flag a little later, and so the most important part from a user's point of view is the DRAM and the CGRAM and CGRAM. Now DRAM, it's a temporary storage device, which is temporary storage memory, which is mapped with the actual LCD. Now we will discuss the DRAM in detail. So basically what it does is that whatever characters have to be displayed on the LCD panel, and these are stored here temporarily. And the next thing is the CGRAM, or the character generator ROM. Now this character generator ROM, it has all the characters that are frequently used. So we have ASCII A to small a to z, capital A to z, then we have numbers 0 to 9, and there are a whole lot of special characters or special symbols. So all those are stored in the CGRAM. So we'll look at this in detail. Now even then we also have a memory wherein we can write custom characters, and this is called the CGRAM, or the character graphics RAM, and we can store a total of 8 characters in this CGRAM. Now again, this LCD driver, from the previous image, you could get to know that there are 16 common lines and 40 segment lines, and you can switch the 4 extensions depending on the type of LCD you have. Now moving ahead, let us go ahead and look at the data RAM structure. So the data RAM that we have now, this could answer a lot of our questions. So let us go ahead and look at the data RAM. So the controller has 128 bytes of data RAM, but out of these 128 bytes, only 80 bytes are used by the graphics controller. Now the arrangement of this is very important in order to understand how the LCD displays characters. Now if we write it in decimal, so only the 80 bytes are used out of 128. Now if we write it in decimal, so, and if we start it with 00, if we divide it by 2, then the last would be 63. So let me just write 63 here, and then the next line would start at 64, and then it would end at 127. So okay, so this is pretty important. Now what happens is, so since only 80 bytes are used, so the first 40 are on line 1, so these are 0 to 40 in decimal, and then these are the next 12, so it would start from 64, and then 64 plus the next 12 would be 100, and next 40 would be 103. So this are the 40 characters from 0 to 40, and the next 40 would start from 64 and end on 103. So these bytes, these 12 into 2, which is 24, these are not used. So these are not used by the display. Now if you write this in hex, so this would be 0x00, and this would be 0x27, so 40 is 27 in hex, and then this would be, now see, you can see this gap here, so the 64 would be 0x40, and the next is 103 would be 67 in hex. Now the important point here is the LCD, it's physically mapped with the data RAM. So if the address counter, or the address counter, if it is pointing at location 00, the ASCII value at this particular location will be displayed on the LCD, and this is the first location. So similarly you have second, third, fourth till the 40th location, and this is your 2 lines on the display. So the starting address of the first line would be 00, and it would end at 0x27 or decimal 40. Now for for example a 16x2 display, the starting address would be 00, and since we only have 16 characters, it would end at 0f, or 15 in decimal, or 0x0f in hex, and the next line would start at 64 in decimal or 40 in hex, and it would end at 103. Sorry, not 103, it's 64 plus. So we have 64, including 64 there are 16 characters, so 64 plus 15, this would be 9, and this would be 79. So this would be 79. So 79 in hex 40, so it would end at 4F in hex. Alright, so if you have a 16 cross 2 display, the starting address of the first line would be 00 and 00 in hex, and it would end at 0x0f. So this is the end of the first line. So 16 characters would end at 0f in hex, and this would start at 40 and they would end at 4f. Now we could guess the why the addresses are starting from these numbers. So later we'll go ahead and look at what addresses we need to send in order to display a particular character. Now, so just remember from this video that out of 128 bytes, 40 are mapped. First 40 are mapped to the first line, and then there is gap of 12 bytes, and then the next 40 are mapped to the second line. So this is line 1 of the LCD, and this is line 2 of the LCD, and the hexadecimal addresses would start from 00 to for a 16 cross 2 the 16 characters would end at 0f and the rest is not used, and for the second line it would start at 40 and end at 4f. Let us go ahead and now look at the relation between DRAM, the CGRAM and CGRAM. Now, if you watch the video, what we're doing is we are displaying the entire RAM here. So what happens is, in the first part, and these are the higher 4 bits and these are the lower 4 bits, so in total that makes a byte. And what you could see is, if we run through ASCII codes 0 0 0 0 all zeros to FFF, it would display the first line on the LCD. Since we are using a 16 cross 2 LCD, what you could see is, you could see that the first 8 characters, these are displayed from the CGRAM. So CGRAM, we already stored some custom characters and it is displaying on the first line, and these 8 characters are again repeated from the addresses. This is 8 to 15. So again the characters are repeated, so you get 2 sets of 8 characters on line 1, and these are all custom characters. And on the second line it is blank because there are no characters on the second line. Now if we go ahead and keep displaying the contents of the RAM, you would get all the characters that are displayed on the table. Now what you could see is, like, say for example 0, so the higher nibble is 0011 and the lower nibble is all zeros. So this is 30, and you already know that 30 is ASCII value for 0. So this particular map is according to the ASCII table chart, and so all these custom defined characters, these are stored in the ROM, and the user defined characters are stored in RAM. And you could also observe that the address for the first character in CGRAM is the same. I mean, even if you give the address as 008, or 00, the first character in the CGRAM will be displayed, as you can see in the video. Now, so moving ahead, so what you can conclude from here is, if you want to display data that is stored in the ROM, we need to just send the ASCII value. And if you want to display data from the user memory or the CGRAM, then we need to send ASCII values 0 to 8 or ASCII values 1 to this is 9 to F. So if you do that, then we'll get the custom characters on the display. Now let us go ahead and look at the instruction set one more time. So basically, all the instructions that we send from microcontroller to the LCD, for all of these, register select would be 0 and read write would be 0. So register select, when it is 0, it selects the command register, and when read/write bar is 0, it does an write operation. So we are writing into the LCD. Now the first command, if both these are 0, the first command, if we send a 1, it clears the display. Similarly, if the D1 bit is 1 and irrespective of D0, it gets the cursor back to the home position, like it gets so if you have a 16x2 LCD, it gets back to the first line, first position. Now irrespective of what the star is, so star is don't care. So if you give 1 0 or 1 1, the cursor would go to the home position. Now this you could observe in the video. So this is an important piece. So if this I/D, it stands for increment or decrement. So speaking about the cursor position. Now if I/D, if it is 0, then the cursor decrements. So as you can see in the video, the cursor is on 8th position, and if we decrement the cursor, it goes back from 8th to 7th position. So if these are 0 to 16 positions on our LCD, so if we make increment decrement as 0, and this shift is basically the entire display shift. So if we make both these bits as 0, the cursor, if it starts at this position, then it starts to decrement and print the values. Like say if we display hello starting from this particular position, the cursor comes here, displays letter H, then it decrements, displays letter E, then goes back again L, L and O. So similarly, if we make this as decrement, so if it is 0, it decrements, and if we shift the display along with it. So now this, if you observe the video carefully, what you could observe is, what it does is, it first displays the letter, and as soon as it displays, it decrements the cursor. So from the 8th position, the cursor goes to 7th position, and then it shifts the entire display towards left. So once it does that, you get a letter here. Now similarly, you could observe the pattern for increment being 1 and shift being 0. This is normal way in which LCD is used. So when the increment is 1, what it does is, it displays a letter and it increments to the next position, and it does not shift the LCD. So if you continuously display characters, they keep on displaying on the line. So similarly, you can instead of just incrementing, you can increment and then shift. So that altogether, it increments and keeps shifting. You can watch in the video. Now the next command is to turn on the, now if this bit is 1, with D1 you can turn on the display. If it is 0, the display is turned off. With C as 1, the cursor is turned on, and with B as 1, the character blinks. So if B is 0, the current position of the character does not blink. If it is 1, the character blink. Now the next is again the cursor move and shift display command. If C is zero actually in this position, now it shifts to the next position, and to do this shift the command should be, so this bit, now we are shifting towards right, so this bit should be 1, and we're not shifting the display, so just the cursor that is shifted, so this would be 0 1. So now what this makes is 1 and 4. So if you assume these two bits are 0, this would be 1 4. So if we send a command 0x14, it would shift the cursor from the home position to the first position. Now similarly, if you want to take the cursor back to the first position, the command would be, this would be 0, we're not shifting the display. This would be 0 because we are shifting it to left, and these would be 0 0. So this would be 1 0 in hex. This gets the cursor here. Now after that, what we do is we simply display a string hello, and then we want to shift the entire string towards right. Now as you could guess, so since we want to shift the display itself, so the S is turned on, and to display it to the right, since this is R, so we need to make it 1. So this would be 0x1, and this is C. So if you give the command 0x1c, the hello just gets shifted from the first position to the second position. So what we get is, now again, if you want to take it back to the first position, we need to give the following command. So what we need to do is, we need to make shift as 1. We want to get back to the left position, so we want to shift it towards left, so this would be 0 and this would be 0. So the command would be 0x18. So the hello from this position where it was before, it comes back to the first position. Now what you could see in the demo is a slowed down the entire program, so that you could observe clearly as to what is happening. Now so with this command, so if we give 1 4, it shifts to the cursor shifts to the right, and if we give 1 0, cursor shifts one position to the left. If we give 1 C, the entire string is shifted towards right, and if we give 1 8, the entire string is shifted towards left. Now let me just clear this off. So the next command is function set. So what this does is, this command, in fact, it defines whether a LCD is has a 4-bit interface or a 8-bit interface. It also determines whether it has 1 line or 2 lines, and also defines whether the font size is 5x8 or 5x10. Now if the bit DL, if it is 0, then the LCD is in 4-bit mode. So by 4-bit we need only D4 to D7 data lines are used. If it is 1, the LCD is in 8-bit mode. With N, if it is so if the N is alright, so let me just check here. If N is 1, then it is a 2-line display. So, and if N is 0, it's just 1-line display. Alright, and the F, if it is 0, it is 5 cross 8, and if it is 1, then it is 5 cross 10 dots. So if F is 0, the font is made of 5 cross 8 pixels. If it is 1, it is made of 5 cross 10 pixels. Now let us take an example. Say for we have a 16 cross 2 LCD as in demo, and it has the character font size is 5 cross 8. Now, so the bit pattern for this would be, so this would be 0001, and sorry, so looking here, so this would be 0001, and this display length or data bus length, it would be say we are configured it in 4-bit mode, so that would be 0. And the next is font size, so we want to keep the font size as so the next is, yes, the font size. I think I missed a bit here, so this is DL0001, so yes, this would be 1 again. So let us do it one more time. So we want the LCD to be in 4-bit mode. It is a 16 cross 2 LCD, and we want the font size to be 8. So for this the command would be 0001. Then we want it to be in 4-bit mode, so DL would be 0, and then the number of lines that our LCD has is 2, so N would be 1, and the font size is the default font size, which is 5 cross 8, so this would be 0, and these I don't care, so if we take them as 0, the command would be 28. Similarly, for a 8-bit mode of a 16 cross 2 display, the command would be 001. The DL in this case would be, since it is in 8-bit mode, so DL would be 1, and the number of lines will be again 2, and the font size would be 0. So this is 00, so this would make 38. So this is a pretty important command which defines the interface, the font size, and the number of lines the display has. Alright, so let me just clear this up. Alright, so now what we could also observe is with the commands, the one is shifting towards the MSB. So I left with only a couple of commands here. Now these are two important ones. Now this, if the D6 bit is 1, alright, so the next addresses would point to the CGRAM. So as we have discussed, so this we can use it to store custom characters. Now what you could observe from this is there are only 6 lines or 6 address lines that you can give here, and the address range would be from 00 to 3FH. Now we'll discuss this, just have this on back of mind. So when we will be discussing how to display custom characters, just remember that before we go ahead and display, we need to write to the character graphics RAM, and in order to write to the character graphics RAM, we should first send this command in order to send the address on which we need to write on the CGRAM. So the command would be 01 followed by the address where we want to write, and just remember that this is just a 6-bit address. And to give you a hint, we can just display 8 custom characters on this particular LCD. Now the next obvious command is 1 followed by 7 bits. So 7 bits, it would be 0 to 127. Now as we have seen before, the internal RAM or DRAM is 127 bytes, and out of that 127 bytes we are using just 80 bytes, and we also know the addresses and how they are mapped with the physical LCD. Alright, so let us move ahead, and there are other 2 commands. Like say we select the CGRAM or the DRAM, and if you want to write data to that particular RAM, what we need to do is we need to select the register as data registers. In all these commands, since we are sending these commands from a controller to an LCD, all these were, and the register that was selected was command register. So if you want to transfer data, and if you want to store data into the LCD, or in fact if you want to display the data, the register select would be 1, and if you want to write data, again the read write line would be 1. So this is register select and this is read write. Now once we make this combination, we can write data into this. Now in that case, the entire D0 to D7, this would be our addresses, or this could be our data. So what we usually do is we set, say for example we want to write bit pattern for a custom character. What we do is we send this command, and then once we send this command, what we do is we make register select as 1, read write as 0, and then we send consecutive data which is stored in the RAM. And if you want to display data which is already there on the character graphics ROM or the RAM, what we do is we send the address with this command, and then we send this command, and after we send this command, we make register select as 1, read write as 0, and then we send the ASCII value of whatever we want to display. Like say if you want to display 0, what we do is we send this command and we send the position where this needs to be displayed, as we have discussed. So if you want to display it at the starting address, the command would be 1 followed by all zeros. So this would be first position on the LCD, and hence it would start with 0x80, and since we can give we have 15 more such characters for a 16-line display, this would go from 80 to 8F. Now, and similarly for the second line, if you want to display it on 2 lines, this bit would be 1, and then it would start from 100. So this would be C0 and this would end at CF. Now you know why the addresses for the first line start with 80 and end at 8F, and for the second line they start at C0 and end at CF. So this is how we write custom the characters that are already there in the ROM with this command, and if you want to write the custom characters, we use this particular command. Alright, so let us go ahead and see how we could write custom characters on the LCD.